And here we are again. Okay, so this is the new and improved version of AT01. See, I think the original AT01 hates me. So, long story short, new AT01, ready to rock and roll. We talked about this today, and this is what you were going to see yesterday for AT01, but I think it's worth going over again very briefly. Important terms to know about circle angle theorems. A tangent line. It's a line that touches the circle at one point, and that point, and I don't have it on here, is called the point of tangency. Okay, point of tangency. And you're going to need to know that as we go through the school year. Okay? The secant, it's kind of like a chord, but a secant goes through the circle in two spots. Okay, so let's draw a couple of pictures to see here. So if I have my circle here, a tangent line touches only one point of the circle. A secant, however, goes through 2 points. It cannot be the diameter, though. That's not a secant. A chord, it's kind of like a secant, but it doesn't go through the circle points. It just kind of lays on both sides edge. And radii, we know what that is. That's just the radius of a circle. We can reference multiple radius as radii. Okay. Moving forward, let's get into the actual theorems. Pretty easy overall. Number one, central angle theorem. Basically what it says is, if I have a center of a circle that's identified and an angle protruding to either side with 2 radii, I have the same measurement of the arc as I do for that angle. Okay, so this would be 82 as well. Right? Inscribed angle theorem, number 2. If an arc intercepts, or if an angle intercepts its adjoining arc on this side, x represents 1/2 of the angle or the arc that it comes in contact with on the side here. So this angle is 1/2 of this arc. So this would be 41 degrees. Obviously, if I have another one, you would double it to get to the arc. Depends on what I'm asking you. Okay. And again, what's in this pale colored square or rectangle is very important for you to remember. So you want to take notes on that if you haven't already. Number 3, tangent chord angle. Basically, a circle has a tangent with a point of tangency and a chord that comes through it. Okay, represented by the inscribed arc. Okay, multiply that by 1/2 or divide it by 2, and you get the angle measurement here. Okay, so the measure of ABC is 1/2 of the intercepted arc. Okay. Number 4, angle formed by 2 intersecting chords. Okay, so this one's probably the most challenging of them all. Basically, if you have 2 chords going through any part of the circle and it doesn't go through the center, you're going to add both arcs together and you're going to divide by 2 to get the angle that's formed here. So for example, on this one, 32 plus 54 is 86. Divide that by 2 and you get the intercepting angle. Okay? This is for 2 intersecting chords. Okay? Not secants, chords. Where's my clicker? Clicker. All right, Theorem 5 has a couple of subsections, 3 in fact for right now. The first one is angle formed outside of circle by intersection, outside of the circle, 2 tangents, as you can see by the diagram here. Now, all 3 of these subsections have the same exact methodology, but you do have to make sure you're very clear on how this works out with the actual tangent secant kind of. Right. So 2 tangents, major arc minus minor arc, okay, divided by 2. And that will give you the angle. So for angle B, okay, major arc minus minor arc, so 240 minus 120 is 120. Divide that by 2, or take 1/2 of that, and I get 60. So the angle measurement for B is 60 degrees. Okay? So again here, super important, major arc minus minor arc times 1/2 or divided by 2, and that will give you the angle. 2 secants, same theorem. 2 secants here, right? And these would be chords, so chord BC, chord DE. Okay. Same exact principle. Major arc minus the minor arc divided by 2 will give you angle A. Okay, so 100 minus 30 is 70. Divide that by 2. The measure of angle A is 35 degrees in this particular instance. Okay. Now remember, just quick note, a major arc would be represented by the bigger section, right? So not arc CB or arc ED, just the arc that's on the far side of where the angle is. Okay, so kind of like the intersecting arc. Last one would be a tangent and a secant. Tangent, point of tangency is B. Secant is line AD and chord CD, but that's not relevant right now. Same exact principle yet again. Okay, so we're seeing the same thing over and over again. Major arc minus the smaller arc or the minor arc divided by 2 will give you the measure of angle A. So 164 minus 70 is 94. Divide that by 2. The measure of angle A is 47 degrees. Okay, so this is ATO1. ATO2 coming at you. Bye-bye.